Now in this lesson we are going to work out a problem from combination of resistors. This is not a difficult problem, but when you see the circuit diagram you might feel that it's pretty complex. We have already done one simple question before. Hope you remember that. So let us work this out. Combination of resistors. Problem 2. Hope you remember the old one. So we name it as problem 2. So let's work out this question. Here is the diagram, and here you have a 3 ohm resistor, and then there is a 6 ohm resistor and an 8 ohm resistor. 3 ohm here, 6 ohm, 8 ohm here. Now we connect them together in a circle. Okay, I'm trying to make it nice. Let me see. Okay, here we go. Alright, it forms a kind of circle. Yeah, this is the way it looks. We mark the 2 points A and B. So we are going to apply the power across A and B. And then we need to find out the effective resistance of the circuit. Now, when you look at this diagram, often you get confused which resistors are in parallel and which resistors are in series. And there is no easy way to sort this out. You need practice. So, let us find the effective resistance of the circuit between A and B. Now if you get confused, let me explain. Look at 6 ohm and 8 ohm resistor. So 8 ohm 6 ohm resistors are connected together at this point. The other two ends are connected together with a conductor which is semicircular in shape. So if you pull those two ends together, and then that end you can connect to B, then you realize 6 and 8 ohm resistors are in fact parallel. Do you get that idea? 6 ohm, 8 ohm resistors are in parallel. Now take a look at the 3 ohm resistor. So 6 and 3 ohm resistors. So we'll make them together, the 6 and 8 parallel. So the common end of 6 and 8, one of them is connected to 3. So let us draw the equivalent circuit. You might find it a little bit surprising. How does it look? So first we will just connect the 6 and the 8 ohm resistors parallel. Here you go. There is the 8 ohm resistor here. And down here we have the 6 ohm resistor. So they are connected in parallel. So that end we are going to connect B, Now the other end, you have to connect the 3 ohm resistor. So far so good. And that goes to the point A. Now the trouble comes. Yeah, these two ends are connected together. Now you can see that the end B is connected to the end A with a semicircular conductor. So look at here now. What happened in here? The point is A. So what is the outcome? That point is A. Now, what would be the effective resistance of this circuit? Because when you look at it, you can see that A and B are connected with a conductor together. So they are short circuited. So the rest of the resistors becomes irrelevant. So the effective resistance of the combination becomes true. Look at it, from A to B it's a semicircular. No, it's a nearly circular conductor. A to B is a nearly circular conductor. You are connecting across. So the additional resistors you connected would not make any difference. So the effective resistance of this particular combination becomes 0. Now let us modify the circuit a little bit by adding one more resistance to the circuit. Yeah, that part is removed and probably connect a extra resistance there. So it's nearly the same circuit with one resistor added to it. Here you have the 3 ohm resistor. This is 6 ohm and then 8 ohm. Now you can see the difference. There is an additional 6 ohm resistor is connected and the equivalent circuit changes. You can see that how the equivalent circuit changes. Now you can see that 6 ohm and 8 ohm are connected in parallel. So the effective resistance of that combination is 6 times 8 upon 6 plus 8. That is 48 upon 14. If you simplify this, 24 upon 7. So that is and that one is connected now to a 3 ohm resistor in series. So that works out to 24 upon 7 plus 3. So that is equals to 21 plus 27. 24. 21 plus 24 is 45 upon 7 ohm. And that one is connected in parallel with the 6 ohm resistor. 45 upon 7 times 6 upon 45 upon 7 plus 6. So let's work this out. 5 6 are 30, 6 4s are 24 plus 3 27, 270 upon 7, the whole divided by 7 6 are 42 plus 45, that 87 upon 7. So when you 7 and 7 get cancelled, you get 270 upon 87 ohm. So this is the effective resistance of the combination. Thank you for listening to this short lesson. Thank you very much.